All right, ladies and gentlemen, we're going to go ahead and work on our next set of Module 5 notes. Again, recorded at home so that you can enjoy the sound of my children screaming while they play Mario Kart in the next room. This is going to be Module 5, Lesson 11. Lesson 11 is very much like Lesson 10. We're talking about area of rectangles again. The only difference here, and it's not a big one, is that we are going to pretty much have exclusively mixed numbers. In the previous lesson, we had some whole numbers. We had whole numbers with fractions, so mixed numbers. But in this case, area of rectangles with mixed numbers, pretty much all we're going to be doing. Now, I mentioned in the previous lesson, if you feel like you want a refresher on how to multiply with mixed numbers, you're going to want to look back at Module 3. Module 3 or 4. You're going to want to look at previous modules. Go ahead and refresh your memory on that. Okay? Area of rectangles with mixed numbers. This is going to be 10 plus one more. There we go. Now, the vocabulary that we're going to be using today is pretty much identical to the previous lesson. So rather than go through that, I'm just going to refresh your memory on a couple of key concepts. Number one, please remember that the area of a rectangle is equal to the length times the width. We've been talking about that a lot. You are familiar with that. I'm just including it quickly to make sure that we all have it on this particular page. Area of a rectangle is length times width. I got a great question. Can it be width times length? Commutative property tells us absolutely yes, it can. All right, number two. I must be getting towards the end of a race out there. Number two. Change mixed numbers. Change mixed numbers into improper fractions. Change mixed numbers into improper fractions to more easily multiply. Okay. If you have two mixed numbers that you're multiplying together, and you will have a lot of those, go ahead and make sure that you are changing them to improper fractions. Okay. Now, we'll dive into the process, which should look pretty similar to what you did in, again, the previous lesson. Number one, step one, sketch. Now, the word sketch is important because we are not drawing a perfectly beautiful rectangle here. We're going to do the best we can to make it look good, but it does not have to be perfection. Okay? Sketch. Sketch the rectangle. Sketch the rectangle using the given. My brain mixed those words up a bit. Sketch the rectangle using the given dimensions. I think I did it again. When we're talking dimensions, in this case, I want you to be thinking again, length times width. When we talked about volume and 3 dimensions, we had height going on as well, but in this case, just length times width. All right, let's work with this one, with these dimensions. Let's go 2 1/4, let's say inches today. 2 1/4 of an inch times 2 let's say 1/3 of an inch. Now, yesterday we worked with mostly halves. In the previous lesson it was mostly halves, which was really nice. This is going to be a little different, obviously. For this, it's going to be harder to just count up the tiles. Okay? Still kind of possible, but we'll talk about that in a minute. When I'm drawing this, I'm going to start 2 1/4, 2 1/3. I'm going to see which one is longer. That'll be our length. Just so happens to be this one. Remember, smaller smaller divisor Wow. Divisor's better, but my goodness. We'll pretend I'm doing this on purpose. Folks, you're pausing your video and you're yelling, Mr. Landre, that is called the denominator. Denominator. I had to run through all my D math terms, apparently. Denominator. Sorry, folks. Smaller denominator means fewer pieces, which means bigger pieces. So, 1/3 would be more than 1/4. Wow. I had some trouble with that. Okay, let's go ahead. So our length will be about 2 1/3. And then again, this is 2 1/4. Now, this 2 that I drew that's way long. I'll tell you a secret. You do not have to draw these to scale. Okay? You do not need to make these exact. This does not need to be drawn to scale. This does not need to be perfect. Okay, I said sketch. We are going to say this is 2 1/3 inches. It's not. If I get out my ruler, try to measure that, it's not even 1.5 inches. So this is definitely not 2 1/3. It's about 1 inch, a little less. It's okay. It's okay. Okay. We'll put our width right there. Again, this is our length. This is not drawn to scale. It's not perfect. It doesn't really need to be. Okay. We're just trying to kind of get a visual. Now, I went back and forth on how I wanted to show you the next step, because really, you can do it using the tiling that we used in the previous lesson. However, I don't think the tiling is very helpful. You end up multiplying 1/3 times 1/4, and you end up getting like a 12th, and it's just... So, for step 2, this is going to be the big difference today. This is the big change. Okay. We're going to use the area model. And then in parentheses, okay, split the mixed numbers. Now, what does that mean? And isn't it kind of weird to say use the area model when we're finding area? Admittedly, yes. Okay. But let me show you what I'm talking about. And this is why I keep screaming about it not having to be to scale. We're going to draw a rectangle again. Doesn't have to be perfect, which is good because mine certainly is not. Down at the bottom, where we had our length, what I'm going to do is I am going to just cut this thing into 2 pieces no matter what. This is different than yesterday. Yesterday, we split it up based on how many parts we had. Did we have 4 units? Then give me 4 columns. Did I have 6 1/2 units? Give me 6 and then 1/2 columns. 6 1/2 columns. This time we're going to do 2 every time, because one side is the whole number and the other side is going to be the fraction part. This is what I mean by splitting apart the mixed number. 2 1/3 is just 2 plus 1/3. Sorry, that's getting fuzzy. I'll try to get it to focus a bit better. It's just 2 plus 1/3. So the 2 gets this column, the 3rd gets this column. Now, again, yesterday we would have split this into 2, and then we would have had a little 3rd column. That works. I just don't think it works very well for this. It gets a little awkward. Now on the other side was originally 2 1/4. Well, whole number part plus fraction part, which means I'm going to split this in half. So again, when I say use the area model, it really is that key word right there, the model that we did a while ago. because now I'm going to treat this like a multiplication table, and I'm going to multiply. Okay. Multiply. We're multiplying at the intersections where they cross. Again, think about a multiplication table. Think about the multiplication chart. Okay. Here's 2, here's 2. If I draw invisible lines from both, they meet right here, right? They meet right there. 2 times 2 would be 4. Well, that's pretty easy. Okay. 2 times 1/4 would be 2/4, which is equal, I can simplify 2 times 1/4. 1/4 and 1/4 is 2/4. I can simplify that down to 1/2. Now, 2, this 2, going across, 1/3 going up. 2 times 1/3 is 2/3. Can't really simplify much there. Okay. 1/4 times 1/3, remember we kind of talked about that. This is 1 times 1 is 1. 3 times 4 is 12. Oh boy. So we got some interesting stuff going on here. Okay. We have partial products, but this is not everything. So let's go ahead. Number 3. Step 3. Add the partial products. Now this is going to be a little bit of a bigger one. We've got the whole number 4 plus 1/2 plus 2/3 plus 1/12. Oh boy. Fun! You're not going to do it this way very often, but we're going to do at least one together. More to practice this than anything. Looking at this, it's important to remember that we have to have a common denominator if we're going to add these together. 2, 3, and 12, the one thing that they can all go into, and I know I'm speeding through this a little bit, but the one thing I'm speeding through that they all will go into is 12. So 1/2 would be the same as saying 6/12. 2 times 6, 1 times 6. 2/3, well, I'd have to multiply top and bottom by the same thing. 3 times 4 gives me 12. 2 times 4 is 8. And then 1/12 is already 12, so that's nice and easy. 6 plus 8 is 14. Plus 1 is 15. Okay, so we have 4 plus 15/12, which is the same as 4 plus 1, because I can pull one group of 12 out of there, and 3/12, which is the same as 5 and 3/12. Now, we will do it that way once or twice to practice together. But for the most part, you are going to jump straight down to step 4. This is actually where you're going to begin most of the time. You are going to check with multiplication. You're going to solve with multiplication. Check with multiplication and record. Now this goes way back up to the key concept I gave you, number 2 at the very top. Mixed numbers can easily be multiplied if you change them into improper fractions. So the original numbers, 2 and 1/4 times 2 and 1/3. Length times width, or Width times length, I think we decided in this case. 4 times 2 is 8, plus 1 is 9. This improper fraction is exactly equal in value to 2 1/4. If I have 9 halves, okay, wait a minute. Ah, my goodness. No wonder it wasn't working. Let's try again. Sorry, ladies and gentlemen. 9/4. If we have 9/4, 4 times 2 is 8, plus 1 is 9/4. 9/4. That means we can make 2 complete groups of 4, 4 and another 4, and then we'd have 1 left over. Sorry about that, folks. Let's see if I can do better on this one. 3 times 2 is 6, plus 1 is 7. Make sure you use that original denominator, Mr. Landre. 7/3. Okay. Now, I cannot cross-cancel with the 4 and the 7, but I can with the 9 and the 3. I can divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. When I multiply across, 3 times 7 is 21. Remember, the 9 disappeared. When I divided the 3 out of it, I was left with just another 3. 3 times 7. 4 times just 1 now. That's gone. 4 times 1 is 4. And if I do the long division, if I do the long division, 21 divided by 4, 4 will go into 21 5 times. There will be one little thing left over, 1/4. And if I go back to this nonsense from up here, 3/12 can be reduced down to 1/4. 3/12 can be reduced down to 1/4. I said it before. I'll say it again. We are going to practice using the longer method together just to make sure that you understand how these pieces are fitting together. But folks, honestly, you're going to multiply. You're going to multiply straight across. Tomorrow we'll also practice doing some of the tiling that you're going to see. Again, you're going to end up with these very small tiles. You're going to have 2/3, 1/12, 1. You get some weird stuff. So, understand the area model, how we can split things up that way. But know that you are ultimately just going to multiply length times width. All right, folks, we'll go ahead and stop here. If you have any questions, make sure you record those for when I see you in class. But for now, that'll do. I will see you next time.